Here, we'll discuss about chemical reactions and chemical equations. A chemical reaction is a process. It's a process in which one or more substances is converted to one or more new substances. For example, hydrogen gas, H2. It reacts with oxygen gas, O2, to form water or H2O. And we write a chemical reaction in the form of a chemical equation. So this one is the chemical equation for this reaction with H2 plus O2, then arrow, we have H2O. The substances on the left side of the equation, these are the reactants. The reactants are the ingredients, so these are the substances before the reaction. And on the right side of the equation, we have the products. So the products are the substances after the reaction. So these are the substances formed after the reaction. Now let's focus on this equation first. So as you observe, there is something wrong with this one because on the left side we have two oxygen atoms, but on the right side we only have one oxygen atom. So it seems like one oxygen atom is lost or is destroyed during the reaction. This is contrary to what we observe in chemical reactions. As what we observe, the mass before and after the reaction are the same. It means that the atoms before and after the reaction must be the same. So obviously, something is wrong with this equation. We say this equation is not balanced. So let's try to balance this one. The first thing is to write all the elements involved in the reaction. Of course, the same elements on both the reactants and then the products side. On the left side, let's count the number of hydrogen atoms. First, we have two here, and we also have two oxygen atoms on the left side. On the right side, we have two hydrogen atoms and one oxygen atom. So obviously this one is not balanced. So hydrogen, that's balanced for now. For oxygen, we have two oxygens here, but we only have one oxygen in this molecule. So to explain this, maybe there are two water molecules produced from this reaction. So these are coefficients. So these are numbers before a formula in a chemical equation. So this tells us that there are two water molecule on this side. So we actually double everything here. So again, that's 2 times 1. That's equal to 2. And as you observe here, this oxygen is connected to this water molecule. So again, when I say there are two water molecule, I double everything. So since sumpay sila hydrogen and oxygen here, when I double oxygen here, I also double the amount of H2. So I'll also multiply this one by 2. And that's equal to 4. Let's check the balancing now. So oxygen 2, 2. So it's good for now. But for hydrogen, we have 4 on the right side and only 2 on the left side. And of course, to balance this one, we need to have 4 also on this side. And to do that one, we need to double this oxygen molecule, this hydrogen molecule over here. So that will be the hydrogen. Again, that's times 2. So we'll times 2 this one, and this will be equal to 4. And now let's check. So that's hydrogen 4, 4, and then oxygen 2, and then 2. So this one is now balanced. Let's have another equation. We have Na plus Cl2 producing NaCl. So we have here Na and Cl. On the left side, we have one sodium atom. We have two chlorine atoms. On the right side, we have one Na and one Cl atom. So here we have sodium. It's balanced for now, 1, 1. But for chlorine, we have 2 on the left side and only 1 on the right side. So for this, let's try to double this one. So we'll multiply this one by 2. that's equal to 2. Again, put this number in the equation directly. So we put 2 over here. Again, this is one compound. So damay CNA. So that's also times 2. That's equal to 2. And right now, Cl2, 2. But Na, we have 2 here and only 1 on the left side. To balance this one, we'll try to double also this Na over here. That's equal to 2. So Na, 2, 2, and chlorine, 2, 2. This is now the balance equation. Next, we have CaClO3, 2, producing CaCl2 plus O2. Again, all the elements Ca, Cl, and oxygen, Ca, chlorine, and oxygen. On this side, we have one calcium atom. On this case, we have this 2 over here. This doubles everything in the formula. So here we have 1 times 2, that's equal to 2. Then oxygen, we have 3 times 2, it's equal to 6 oxygen. On the right side, we have 1 calcium atom, 2 chlorine atoms, and 2 oxygen atoms. So calcium 1, 1, it's balanced for now. Cl2, 2, oxygen 6, and then 2. So this one is not balanced. So of course, the LCD of 6 and 2, that's equal to 6. So we'll try to have 6 on this side. To get 6, we need to triple this oxygen atom over here. Again, don't forget to write this 3 on the equation directly. So right now we have 1, 1, chlorine 2, 2, oxygen 6, and also 6. This is now a balanced equation. Next, we have CH4 plus O2 producing CO2 plus H2O. Carbon, hydrogen, oxygen, carbon, hydrogen, and oxygen. Carbon, we have 1, hydrogen 4, oxygen 2. Carbon 1, we have hydrogen, we have 2. And then here we have 2 separate oxygens. So here on this molecule, we have 2. And on this separate molecule, we have 1 oxygen atom. Let's go first to carbon, it's balanced. Hydrogen 4, and then the other side has 2. So let's double this one. Hydrogen over here, we put 2 here. And again, damay si oxygen, this oxygen over here, since we double the H2O molecule. So that's also times 2 on this oxygen atom. That's equal to 2. So right now we have 2 plus 2. So we have 4 on the right side. On the other side, we only have 2 oxygen atoms. To balance this one, we need to actually double this one. Write 2 over here, and then 2 times 2 is equal to 4. Let's check. Carbon 1, 1, hydrogen 4, 4, and oxygen 4, and then 4. This is now a balanced equation. Next, NH3 plus O2 producing NO plus H2O, nitrogen, hydrogen, oxygen, nitrogen, hydrogen, oxygen. On the left side, we have 1 nitrogen atom, we have 3 hydrogens, and 2 oxygen atoms. On the right side, we have 1 nitrogen atom, we have 2 hydrogen atoms, and 1 plus 1. Okay, let's go to nitrogen. It's balanced for now. Hydrogens 3, and then the other side is 2. The LCD of 3 and 2 is 6, right? So let's try to get 6. So for this, we need to triple this one. So we triple this one. So let's put this 3 on the equation. That's on the hydrogen, or on this H2O. That's times 3. And again, since here this H2 is connected to this oxygen, this is also tripled. 1 times 3 is equal to 3. Okay. Again, 1, 1, then the other side 3. Again, we want to have 6. So we'll double this one. And by doing that, don't forget to write this one on the equation. So we have 2 here. We'll write it over here. because this contains the hydrogen. And again here, damay si nitrogen because sumpay sila. So here we'll double this one also. That's equal to, no, sorry, this one is not, we'll have, so again here, this one is connected to this nitrogen over here. That's also times 2 on this case, so that's equal to 2. Let's go back to nitrogen. So here we have 2 and we only have 1 over here. To do this, we need to double this one. That's equal to 2. Don't forget to write this one on the equation. And by doing that, you see that this 2 is also affecting the oxygen on this molecule. So we have also here 1 times 2 is equal to 2. So in this case, we have nitrogen 2, 2. It's balanced for now. Hydrogen 6, and then 6. And here we have 2 oxygen, and on the right side, we have 5 oxygens. So in this case, our goal for them is to have, okay, our goal here first is to have, let's get 5 first. So to get 5, let's multiply this one by 2.5. So the coefficient here is 2.5. That's equal to 5. Okay, so in this case, we have this balanced equation. But on our equation, we want our coefficients to be in whole number. So we don't want any decimal in our chemical equation. To make this whole number, let's multiply everything here by 2. So we'll double every coefficient on this formula. That will be 4NH3. Then here we'll double this one. That's equal to 5, right? 2.5 times 2 is equal to 5. O2. Then double 2. We have 4NO plus 6H2O. So this one is the preferable balance equation for this one. So again, we just double everything here because we want to have a whole number in our chemical equation just to make everything simple. Now there are 4 different types of chemical reactions. The most common type is the combination reaction. It's when 2 or more substances combine to form one substance. We also have a decomposition reaction. It's when one molecule breaks or decomposes into 2 or more substances. We also have single replacement. It's when one substance replaces the partner of another substance. So there is a single replacement on this reaction. We also have double displacement. It's when 2 substances exchanges partner. So there's a double displacement. Now let's try to identify what type of chemical reactions is represented by the following chemical equations. Here we have one compound breaking into 2 substances. This one is a decomposition reaction. This one we have 2 substances combining to form one substance. This one is a combination reaction. This one, Zn plus HCl producing ZnCl2 plus H2. So here this Zn, it replaces hydrogen as the partner of Cl. So we have ZnCl2. So this one is a single replacement reaction. Then here, we have this hydrogen, it partners with OH, making H2O. Then this CH partners with Na to form NaCl. So they exchange partner. So this one is a double displacement reaction.